The topic of this presentation is something that has been, I was inspired by a number of comments that I've been hearing over the last several weeks from senior leaders at Google and at conferences. And this is an idea that has come up repeatedly about Istio and Kubernetes representing a new stack that the first couple of times I heard it, I have to say, was kind of an audacious claim. I thought, well, that's pretty, that's aiming pretty high. You know, with all due respect to Kubernetes, and we've been hearing about it all day long, Kubernetes is phenomenal, and it has a lot to take credit for. But it solves a particular set of problems. I don't know that we can quite call it a stack. And as far as Istio is great, and it adds a lot of value on top of Kubernetes. But it's a fairly young project, and it's version 1. It's version 102. And it's production ready, but if I ask for a raise of hands of how many people are using production, I'd have to ask in a much bigger conference than this to get one hand. So these are technologies with a lot of promise. Whether they are a new platform for a new stack, it's kind of a question that I find intriguing, and I want to try to address. Why do I think that that is being proposed by very serious people? What is it about Kubernetes and Istio that makes them the candidates for being a standard platform for cloud computing? Separating application from infrastructure is certainly not new. It's something that's familiar to all of us. It's nothing that's specific to the cloud. We've all, for many, many years, understood the value of having our solutions, our code running on a variety of platforms, of hiding the underlying complexity from our code, of letting our developers focus on producing business value. The difference on cloud, if at all, is that someone else is managing the infrastructure for us. We don't even have access to the infrastructure. We don't even want access to the infrastructure. So the theme of the separation remains the same, but perhaps it becomes even more acute and more in our interest to ensure that it's being done appropriately. So a little bit of history. Again, we've heard all day long about Kubernetes, but a little bit about how did we get here? How did we get to the point where I can come to a conference in Tel Aviv and hear presentations from Amazon and from a whole bunch of different companies and from tool providers, and everybody has gone Kubernetes, Kubernetes, Kubernetes. So containers have been around for more than a decade. The biggest, most successful companies at providing globally distributed services to audiences of billions have been using containers for more than a decade. They were popularized around 5 years ago by Docker, who made them accessible to all of us without having to have a degree in how does Linux work. And following the popularization of Docker, and also I just heard a good presentation by Mike from Amazon on the 12-factor application and microservices. So that methodology has also driven a lot of interest in using containers, deploying containers, and also clouds and the scale that they allow us to achieve, obviously, have driven a lot of the need for being able to hand your code off to somebody else, all packaged up with all its dependencies, with the entire environment that it needs, in a way that will run wherever they put it, wherever that cloud provider decides to put your code, because they're taking the responsibility for scaling. So it gives us a more lightweight package than VMs that we had before. It gives us the platform independence, gives us a simpler install so that whether you're running it on whether developers are running it on their laptops or in the cloud or in a data center or wherever it is, you have the uniform environment. But over time, and this is another theme that's come up repeatedly today, when you have a lot of containers, those containers need management, right? Those containers need coordination. Those containers allow somebody else to manage for you, bringing them up and scaling them out and killing them off and versioning them and things like that. But they need a system for orchestration. And so more than 10 years ago, the engineers at Google developed Borg, and after 10 years of learning and tuning and improving Borg, created Kubernetes out of all those lessons learned, and gave Kubernetes to the world and said, well, let's be a bit more modest about it, gave the start of Kubernetes to the world and said, this represents our learnings, take this is going to give you a jump start. And Kubernetes exploded into a collaborative effort with many, many contributors realizing the potential, realizing the need for container orchestration, and adding value on top of that. This write once, run anywhere, I don't know how many of you can see on the bottom there, but again, in the theme of nothing new, 20 years ago, Java was promising write once, run anywhere, right? With the JVM, run your code in the JVM. That was Sun's Sisma at the time. And to a certain extent, they delivered. To a certain extent, it still had its challenges. But what the JVM did for our code, containers are doing for our entire packaged stack and full environment, right? So again, there's not brilliant new ideas here. The ability to achieve this separation, well, hang on a sec. Let's talk a minute about what are we abstracting, just in case for the people in the room who aren't enjoying Kubernetes yet. We're abstracting hardware. We're abstracting the compute, the network, the storage. That's basically what Kubernetes is doing. It's allowing you to not care, let somebody else worry about what CPUs are you going to get, what memory are you going to get, what's the network going to look like? And in a cloud environment, it's allowing you to not care exactly what it takes to spin up a load balancer and configure the load balancer. You just say, I need a load balancer. All right, so there are certain cloud native components that you don't have to worry about. You just have to say, I need one of those. And Kubernetes lets somebody else orchestrate what it takes to have it wired up to your system. And in that way, it provides portability. This is good for developers, this is great for developers, and this is good for operators. There has historically been a tension between developers and operators because each wanting to their own control, the developers are concerned about development time and the operators are concerned about runtime and production time and their responsibility to keep the system up. And Kubernetes allows there to be a clean disconnect between those two while empowering both the developers and the operators. That's the history lesson. Let's talk about what's the actual value that Kubernetes provides. For the most part, we come to Kubernetes for the same reasons we come to cloud. Scale, right? We want to be able to scale very quickly. We want to be able to handle spikes in traffic. We want our application, we want somebody else to be able to scale our application up for us, subject to, right, in response to demand in traffic, in response to users coming, our organic growth, or for whatever reason, change in the news, right? Scale up, scale down, scale globally, be available wherever our users are, and along the way, maintain the health of the system. Those are the primary reasons, just as you go to cloud for that infrastructure, as much as you may need, when you need it, and wherever it may be. That's for the most part why we come to Kubernetes as well. There are a number of other services that Kubernetes provides. And Kubernetes, as a result, has done fantastically well. Again, the project has been around for a while, but in the most recent couple of years has had tremendous growth and success. This is community-driven growth, right? This is because, with no doubt in anyone's mind, this is because Kubernetes is open source. This is because Kubernetes has contributions from big players and small players and individuals across the globe. That's what's driving Kubernetes adoption and the eventual acceptance from every player in the industry that this is how people want, this is what people want from their platform. I better provide it. I better provide some flavor of it. Similar to a certain extent to what we've seen historically, 15 years earlier, 20 years earlier from Linux. So Kubernetes has gotten a lot of recognition for this growth and this impact a couple of months ago, this USCON award, and its adoption, pretty much we can say universal adoption. This is an ecosystem that, these two things feed each other, right? The growth in the ecosystem is what is encouraging the adoption, and likewise the adoption, the availability of Kubernetes has grown the ecosystem. This quote from Jim Zemlin from the Linux Foundation, he said first a year ago at their open source convention, that Kubernetes is the Linux of the cloud. And that was a fairly bold claim at the time as well, but it was directional. This is where Kubernetes is becoming. He said it again at Google Cloud Next conference a few months ago, and it got reposted here. And I put the screenshot up because of the response from Dan, which I love. Dan is a product manager for Istio at Google, and he's taken it up a level. I guess he didn't want to be outdone. So it's, to him, not just that it's the Linux of the cloud, it's the Linux of Linux. It's not just a snide comment, right? There's, I think, something thought-provocative to that. So what does that mean? What would it mean to be the Linux of Linux? And what does that mean as a mission statement for Kubernetes? There's an article, I imagine many of you are familiar with the site, The Next Platform. It's a great source for lots of information about cloud and cloud technologies. And they pose the question, which I guess is the same question that I'm trying to ask here. What would it take, what will it take for Kubernetes to become the thing that we just take for granted as our underlying operating system of the cloud, the way most of us the way most of us take for granted Linux as the operating system that we will run on in production? So, I excerpted this one paragraph. The piece is longer than this, and he focuses, this was written by one of the editors of the site, he focuses on the adoption. All of the big cloud providers, even the not big cloud providers, the West, the East, the tool chain providers, Kubernetes. And that's certainly, a great indicator of adoption. But he asked the question, is that enough? Is that really what it takes to declare success, to declare victory? Is it enough to have thinned out the competition, as you saw in the earlier graph, of kind of those other projects? Mesos, a couple of years ago, was not clear at all which of those two would achieve greater adoption. Is it enough to say, well, look, we're on a Windows server, that's got to say something? Or is there more that we need to ask of Kubernetes before we can really say mission accomplished? And the point of this piece is usability. Usability is key. And there was a slide one of the presenters earlier today put up of this lovely green field of what you expect when you come to Kubernetes and the complicated machine with all the gears. And there's a lot of truth to that, right? Kubernetes, beyond the first demo, it's complicated. It's complex is maybe a better word. You have a tremendous amount of control. And if you want to get it really right, if you want to use Kubernetes in production, you need to take some time to study it. You need to take some time to understand the implication of those configuration options. So there is still room for significant improvement in Kubernetes usability. At the same time, let's give credit to all of the tools. If you do a search for top Kubernetes tools, you do that search today, and you do that search a month ago and a month from now, you'll get articles, top 10 Kubernetes tools, and they're different every time, because the ecosystem is really moving, it's really developing, and it's amazing. I mean, some of the things people are creating and then just giving out, it's super, it's very encouraging, it's challenging to keep up with all of that, but it's the sign of a very healthy ecosystem. What I hear a tremendous amount in meeting with companies, and especially in meeting with the kind of companies we don't have that much of in Israel, enterprises. The enterprises need Kubernetes to exist not just in the cloud, not just in the data center, where it is already, but to be fully managed in the data center the way it is in the cloud. That's what they're waiting for to adopt Kubernetes, because they want to have, this, I love this term, single pane of glass, right? One place where you can look to manage your Kubernetes cluster, regardless of which cloud it's in, regardless of whether it's in your data center, on-prem, whatever it is. So if we want to be able to speak seriously about multi-cloud and hybrid cloud, we need to get to that point, and this is something that Google has acknowledged, and in our next conference a few months ago announced managed Kubernetes. We like to announce things a little bit before they're actually available, but it's an ambitious announcement. It's something that we're working on, and I'm sure that the other cloud providers will follow shortly with providing managed Kubernetes on-premise to connect to your managed Kubernetes in cloud. So those are some of the growth areas for Kubernetes. And basically what it comes down to, if I had to summarize in 2 words, is sufficient abstraction. Kubernetes is providing services now. I'm not sure they're sufficiently abstracted that it's easy to think about them and easy to actually get them right. So I just came out of the AWS presentation on 12-factor apps and microservices. And if you're here, you're likely working at a startup or a young company, and this is your, this is your lifeblood. This is, practically religion for startups, developing microservices and following the philosophy and methodology of the 12-factor app. For enterprises, it's a holy grail. They understand the vision, but it's an extremely difficult one to pursue when you've got a tremendous amount of very big monolithic legacy code that you're not going to walk away from or rebuild anytime soon. I love having somebody in the audience nodding. It's thank you. The reason both the enterprises and the startups and every company in between them is so in love with the idea of microservices and 12-factor is nimble, right? Everybody wants to be nimble. Everybody wants to be able to move fast, to iterate fast, to have small teams, right? Two-pie teams, what's the term? Right? So that you're working independently, iterating quickly, trying new things, testing new things, and delivering value to your end users. That's the goal. That's something we can all agree on. And so there's more and more a trend to microservices, and microservices are, they come with a cost as well. They come with a certain amount of complexity, and that is perhaps the challenge of Kubernetes. Because you've got now all of these microservices, but do you really know what's going on with them? Do you know where they are being deployed and where they're running and how they're connected and what is the latency between them? And latency really does matter. I think we all became extremely aware of latency several years ago with a shift to focus on mobile first, mobile everything, everyone's mobile, you've got to be mobile. Every website, I'm sure you've seen articles about how your users drop off with every second of latency in websites. It's certainly something we paid a tremendous amount of attention to. But even if you're not focused on websites, you might be in the ad industry, right? And latency is super critical when you're responding to a bid and participating in an ad auction. And if you're in the gaming industry, latency is super critical so that your users feel there's live action going on. Whatever your industry is in, there are, I'm sure, areas where latency is critical to you, and you can't turn a blind eye to whether your code is running 50 feet away from your end user or several continents away, and what are the dependencies it's got with other services, and where are those services running. So it's an issue that we need to be concerned with, and we need to have some visibility into, and ideally some control over as well. So at Google's and companies like it, where we are used to having hugely distributed applications and hugely distributed user bases, we've understood the need to be able to monitor and rewire on the fly the connections between our containers and our microservices. We know that we need infrastructure support for A/B testing, for blue-green testing and canary testing, and all kinds of other patterns that you're likely familiar with that go back to the same idea of being nimble and allowing your developers to iterate fast, test new ideas, see how they work, see what value they add, push them to production, and move on. It's probably no secret that companies like Google are doing thousands of A/B tests every single day. Somebody has an idea, they don't need permission, they just implement it, they publish it to a small segment of traffic. When you have enough traffic, you can afford to do this, and all the time you get enough data quickly enough that within a day or a few days you have statistically relevant decision. Is this better? Is it worse? Push and go. Companies like Netflix and Lyft, there's a reason that they're providing the tooling that we're all adopting because they understand the value of iterating quickly like this. Kubernetes doesn't really give us the tools to do A/B testing and blue-green and canary testing in a natural way. So with all this accumulated experience and this culture of being nimble and working quickly and agile. The idea was born for a transparent, some transparent tooling around the networking between our microservices. And let's focus on, I want to focus on the keywords on the slide. What does it mean that it's transparent? Istio is a service mesh. And Istio is not the only service mesh. I'll get to that in a second. But the idea of a service mesh, encapsulated here in a nutshell, says, first of all, transparent means the code of your application doesn't know about it, doesn't care about it, and doesn't need to change in order to apply the service mesh. The service mesh gets transparently aligned above, and your code doesn't know it's there and doesn't feel it's there. Your end users don't know it's there and don't feel it's there. There was a presentation on distributed tracing, and I was expecting that this is where she was going to go, because yeah, it's a fact that if you need to, in all your code, in every one of your functions, insert 2 lines at the beginning and 2 lines at the end to enable tracing, it's going to be spotty. The idea of the service mesh is don't implement tracing anywhere. Let me take care of that outside of the application. Language independent is because it's the nature of microservice-built architectures that different teams use different languages as is appropriate for the component they're building, whether it's because of their skill set or whether it's because it's got capabilities that are unique to the problem they're solving. So a good service mesh and a good infrastructure has to support whatever language you're using. And automated because we're living in a world where 99% isn't good enough. It has to scale fast. It has to respond to challenges of live networking situations immediately in an automated way, so as to achieve the uptime and response time that we want for our users. So as I mentioned, Istio is not alone. There are other service meshes. There are service meshes that existed before Istio. These players are still options out there. You're welcome to try them out. The slide goes through the core capabilities of any service mesh. Some of these I've been talking about, but when you've got communication constantly going over the network, well, who's handling the retries? Is that something is that logic you have to develop yourself, how to do and when to do and how many times to do a retry of a remote procedure call? Who's doing failure prevention so that if a particular node is not responsive, that doesn't cause every caller, its caller and the caller of that caller? No, I didn't get to my demo. He's killing me. I gotta move faster. All right, guys, I want to show you Istio a little bit. So, collaboration, open. Istio was invented or was created by Google, IBM, and Lyft, and was from day one created as an open source project with the goal of this can only succeed with community involvement. That's what made Kubernetes what it is, and that is why we believe that Istio can be the next piece of the puzzle to create this cloud operating system. I wanted to respond to some of the comments I heard earlier today about monitoring and the challenges of monitoring. It's got a bit of a bad rap during the keynote this morning. And no doubt that, monitoring, first of all, we each interpret monitoring in a different way. We each have different needs for monitoring. It comes to solve different problems. But it's not something you can ignore. If you are serious about having a globally distributed application serving a global audience, you can't turn a blind eye to monitoring despite the complexity that it may have. And this is also an area that's maturing, and there's tooling out there, and these tools are getting better. What you want from your monitoring, though, is you want it to be transparent as well. You want the monitoring to be enabled without requiring that you go into your code and you add monitoring to the code. You want it to be language independent so that you don't have to worry about monitoring libraries for every different microservice. And that's one of the core values that Istio gives us. Maybe I need to go past this, but some interesting comments about one approach to monitoring, the SRE philosophy at Google. And there's a book, the site reliability engineer, so Google have written a book on SRE and about monitoring and what to monitor, how to monitor it. And this philosophy that we see being coded into Istio now very much comes out of that SRE experience. We all understand what traffic is and what errors are. Saturation, it's different for every one of us. It depends on what you've built. It depends on what your solution is. It might be the number of games going on at a server at any given time. But the point is to define what are the metrics that matter to you, and then take advantage of the tooling to get some visibility into what's going on so that you can fine-tune and respond to situations as necessary. There's a story I can't help but tell, even though I want to get to the demo. Several years ago in America, the Obama administration launched a healthcare initiative where there was, healthcare for all, and that was enabled by a new website where all Americans could come if they didn't have healthcare and sign up for a healthcare program. And when they launched the website, they very quickly found it's not that easy to launch a website for all Americans. And it had, let's call it, some reliability issues. So a number of Google engineers went to Washington to volunteer their time to support this thing and figure out, these were SRE engineers, to take their expertise and see how they could help keep this website, alive and on the air. And they asked the team in Washington, how do you monitor the system? And they pointed to the screens where they had CNN. And the way they were seriously, CNN was their channel for finding out when the system went down and when they needed to respond to a situation. So most of us don't have and don't want quite that exposure where CNN is going to inform you, and you don't really want to wait till it gets to that point either. I mentioned the ideas earlier on about A/B testing and blue-green testing, and these are, core enablers of the nimble approach that we're after, about continuous experimenting and rolling out new functionality. And this is baked into the most basic functionality in Istio. Security as well. So the cloud providers are painfully aware that it's not enough to have security at the border, right? Security does not mean a firewall. Especially when you've got a shared environment, as you do in cloud, you have to have security. You have to have mutual authentication between callers and the cloud, and you have to make sure that security as an onion is something we hear very often, that you've got layers of security. So TLS is something that has evolved out of SSL and is far more sophisticated and demanding than SSL. And Istio makes it transparent. You can apply TLS to all communication between your microservices without them knowing about it at all, without any changes to the code. It's simply a matter of configuration. That's one I'd like to show you. Fairly quickly, this is the Istio architecture. How does Istio work? So Istio transparently deploys a proxy in every pod alongside your services, and those proxies intercept all communication coming to and going from every microservice. So, and those proxies communicate with the Istio control plane. Actually, I'll walk through a sequence, but this is also what makes it transparent to the services as well. They are not aware that everything is being proxied to and from them, and so we are able to gather the metrics and apply the TLS and other policy, security policy, and to record metrics as well without any changes to the code. So, all right, only for time constraints, I'm going to skip going over the individual components, other than to point out that Istio is not opinionated. Istio doesn't want to enforce you to use Istio for metrics. Istio is pluggable and modular so that you can use whatever system you favor, whatever system you use, connected to Istio's mixer, and that's where you'll get your metrics. Istio just ensuring that the metrics get to that system. All right, I'm moving fast just because of the time constraint. Let's quickly go through, what happens when there's communication between services. So the first thing that happens before the communication is that when the pod comes up, Istio deploys the proxy into the pod. Okay, Istio pushes, this is Envoy, and it pushes it into the pod, and the pilot component of the control plane deploys. I'm being kicked off the stage. That hurts. The pilot deploys the configuration. Like Kubernetes, Istio uses declarative configuration for security and for network connections. Guys, I feel bad. I guess I didn't manage my time well enough, but I don't. Okay, so I'm wrapping it up. There's more to say. There's a demo. I was going to show what's called the book info demo. You can go to Istio. You can download it yourself. I was going to walk through that and just show you how straightforward it is to do A/B testing, to do canary testing. Do it for yourselves, or come talk to me. Sambol at Google. I'll be happy to work with you, help you guys understand what this can offer to your businesses. Thanks for the time, and sorry to run out of it.